Today is our lecture contraction mapping theorem in metric space. Before starting this theorem, I told you some basic definitions whose useful for proving theorem. I know that you also studied in previous classes functions and metric spaces. Now we define first fixed point theorem. Fixed, let x be a non-empty set and let t such that x to x is set to a fixed point at the point x belong x if tx is equal to x. Again repeat, let x be a non-empty set and let t such that x tends to x be a mapping is said to be a fixed point at the point x belong x if tx is equal to x. Here x is a fixed point of t. For example, first, a translation has a fixed point, has a translation has a single fixed point. Second, a rotation of plane has a single fixed point. If t such that r to r and function of x is equal to x square has a two fixed point. देखिए, given f x is equal to x square and we know that f x is equal to x, so implies that x is equal to x square, implies that x minus x square is equal to 0, implies that x minus 1 is equal to 0, implies that x is equal to 0 and 1 has two fixed point. Now we have defined contraction mapping. Let xd space, let xd be a metric space and let t such that x tends to x be a contraction mapping such that distance of tx ty is less than or is equal to this alpha distance xy for all xy belong x and 0 is less than alpha equal to less than or equal to 1. Now we prove the theorem. T x tends to x be a self map on metric space xd such that distance of tx ty is less than or equal to alpha distance of xy for all xy belong x and alpha belong 0 1, then t has a unique fixed point in x. Proof that given that xd be a metric space and let t such that x to x be a contraction mapping such that distance of tx ty is less than or equal to alpha distance of xy for all xy belong x and alpha 0 is less than 1, then we have to prove that t has a unit fixed point in x. x0 belong x be an arbitrary point in x and we define iterative sequence xn such that xn plus 1 is equal to txn is equal to t power n plus 1 x0. If we put x is equal to xn and y is equal to xn minus 1 in above condition, then we have distance of xn plus 1 xn is less than or is equal to distance of txn minus 1 is less than or equal to alpha distance of xn minus 1 is less than or equal to alpha square distance of xn minus 1 xn minus 2 dot is less than or equal to alpha and distance of x0 x1. Implies that distance of xn plus 1 xn is less than or equal to alpha and distance of x0 x1. So far n greater than m d xn xm is less than or equal to distance of xn minus 1 plus distance of xn minus 1, xn minus 2 plus dot dot plus distance of xm plus 1, xm is less than is equal to alpha n d x0 x1 plus alpha n minus 1 d x0 x1 plus dot dot plus alpha n minus m minus 1 d x0 x1 is less than or equal to alpha n d x0 x1 comma 1 plus alpha n plus alpha 2 plus dot dot plus alpha m minus 1 is less than or equal to alpha n upon 1 minus alpha distance of x0 x1. Since 0 is less than alpha is less than 1, then dx0 x1 tends to 0. Thus sequence xn is a Cauchy sequence in X. Since XD is a complete metric space and we also know that every Cauchy sequence in X has convergent in X, so there exist such that xn tends to x as n tends to infinity. That is, limit n tends to infinity, xn is equal to x. Also we know that T, and given that T is a contraction mapping, so every contraction mapping is continuous, so T is a continuous. Therefore xn tends to x implies that T xn tends to tx is equal to limit n tends to infinity, T xn is equal to tx. Therefore T x is equal to tx is equal to limit n tends to infinity, xn plus 1 is equal to x, implies that x is a fixed point of T in X. If now to show that X is a unique fixed point of T, if there exists another fixed point, another fixed point y belonging X, such that X is not equal to y. Distance of Tx Ty is less than or equal to alpha distance of x by, implies that distance of xy is less than or equal to alpha distance of xy. Since alpha is less than 1, then we get dxy is equal to 0. implies that x is equal to y, implies that x is a unique fixed point of t in x. Hence, every contextual mapping, every contraction mapping on metric space XD has itself unique fixed point in X. Welcome student. Today is our